Is interstellar travel possible? I mean, it's a fair question. It's a fair question. And of course, there's nothing like physically preventing travel to another star. Like there's no law of physics says that you must be contained to the solar system. Like of course it's possible. But I when people ask is interstellar travel possible, like I just did, that's usually not what they mean by possible. Like, is it physically possible? Of course, interstellar travel is physically possible, but there's a big difference between possible and plausible and feasible and achievable. Like there's stages here. And so when people ask me, and they often do, is interstellar travel possible? What they're really asking, is it realistically feasible? Like, could humans do it? And again, someday in the distant future, for enough time into the future, we could probably figure it out. In fact, we're kind of doing it right now. Yeah, we've done it. We're sending probes across to other stars. Like, it's happening right now. Now, we didn't do it for that purpose. I'm talking about like the Pioneer missions, the Voyager missions, New Horizons. All these missions are outside the orbit of the planets. Some of them, especially the Voyager missions, are outside the heliopause, which is like considered the boundary of the solar system. This is where the solar wind from our sun meets and intersects with the general galactic junk. And once you cross that boundary, you're kind of outside of the sun's influence. But all these probes are on escape trajectories, which means they will never come back. So they're just gone. They're very, very far away, and with time, they'll keep getting further. They are either in or are approaching interstellar space. So, yes, we have achieved interstellar space travel with chunks of metal that are slowly losing energy and power and eventually will shut down, just keep flying through the vastness of space, cold and alone. For a certain limited definition of interstellar space travel, we've done it. Kind of slow, though. These space probes aren't pointed in the direction of any particular star because their missions were to profile the planets, and so that's set the trajectory. Now they're just out there going in any old random direction. If they were pointed, like say if the Voyager probes were pointed at our nearest neighbor, Proxima Centauri, which is about 4 light years away, they would reach it in 80,000 years. Okay, interstellar travel is possible if you're willing to just send inert hunks of metal flying through the void for tens of thousands of years. Mission accomplished. So yes, in that limited definition, it's totally cool. But what we're really interested in when we talk about interstellar travel is, at one level, humans traveling to other stars and colonizing worlds and, doing all that stuff. And if we can't do that, then can we at least send active space probes that are going to take some pretty pictures and send those pictures back to us? And hopefully the same people that sent the probe get to see the picture. So in a human lifetime, is this possible? When it comes to human colonization, human space travel, I'm not even going to touch that. The engineering and logistic challenges are so off the chart that, yes, in 5,000 years or whatever, humanity might figure it out. That's not happening in my lifetime, that's for sure, and probably not yours either. So let's take. I'm just not even going to bother talking about that. It's just science fiction. It's just science fiction at this point. So let's talk about space probes that can go to other stars, hopefully a nearby star, take some pictures, do some measurements, send those measurements back to us in a reasonable lifetime. In order to do this, you have to go really, really, really fast, right? Because the Voyager probe's going 36,000 miles per hour. Are going to take 80,000 years to reach the nearest star. No one has a budget that lasts that long, okay? So we need something that gets there on this scale of decades. If we can get to Proxima Centauri in, say, 40 years, and then we'll send a message back that'll take 4 years to get back to us. So like 50 years. Okay, that's like the upper limit of what we're willing to accept. In order to do that, if you want to get to Proxima Centauri in 40 years and it's 4 light years away, then do some math. You have to go 1/10 the speed of light. 1/10 the speed of light. And that doesn't sound so bad. Like, 1/10 the speed of light, that's no big deal. That is so ridiculously fast, it's not even funny. Like, am I laughing right now? No. This is my serious face. I just laughed a little. But that one didn't count. I was laughing at myself. 1/10 the speed of light is ridiculously fast. It's far faster than anything we've ever sent a spacecraft. Yes, inside of particle accelerators, we can send like little nuclei to close to the speed of light. And to do that, we have to build these like giant accelerators and suck up a lot of energy. And that's for like a little tiny particle. We want to send a thing, right? A box with some gear in it to take pictures and make measurements and send that information back to Earth. So there's two main options. One is, the main consideration that you have to worry about is the energy. Like, you have to accelerate this spacecraft, up to 1/10 the speed of light. That's going to require a lot of energy. Now, either the spacecraft can take that energy with it, or we can, beam that energy to it. So let me tackle the first one first, which is the spacecraft taking its energy with it. For the spacecraft to take its energy with it, this is like how rockets work, right? Rockets carry their fuel. The fuel is the source of energy to make the rocket go. Rockets are not going to get you to another star because the amount of oomph you get, the amount of thrust you get from a rocket is good. It's fine. It's cheap. It's easy for getting stuff off the ground, for orbiting around. But to get to the 1/10 the speed of light, you have to carry so much fuel. And the problem here is that the more fuel you add, the heavier your spacecraft gets, which means it's harder to push. And so, it's harder to push, so let's add some more fuel. But now you just made your spacecraft heavier, which makes it harder to push, which means you need more fuel, which makes it harder to push, which means you make more fuel. So you got a problem here. Chemical rockets are just not going to do it. There are other approaches. There are other ideas out there. Most notably using nuclear energy in some form. Nuclear energy, like pound for pound, you get so much more energy out of nuclear sources than you do chemical sources. So this is more efficient. If I take a pound of nuclear fuel, I get more oomph out of it than I do if I take a pound of chemical fuel. With nuclear fuel, you got a couple options here. If you want to explore, you want to make some designs. One is you can carry a bunch of nuclear bombs with you and detonate them off the back of the ship and hopefully design the thing so that you don't simultaneously blow up your ship when you're, blowing up your nuclear bombs. And so it's like drop bomb and the bomb goes off and it pushes and then push like that. Okay, it would take more nuclear fuel and more nuclear bombs than we've ever produced in the history of humanity. Okay, but it's a thing. And the spacecraft would have to be very big and very, very sturdy to survive all these nuclear blasts going off behind it, which is going to make it super heavy. And remember, this thing's got to operate for decades. So it's got to launch nuclear bombs over the course of years and not fall apart. Is it a good idea? Is it a bad idea? I don't know. It's like when you start adding up the numbers to make this kind of spaceship happen, it gets really expensive really fast. More money than is available in the world in a year. So if nobody spent anything, nobody ate, nobody went to the movies. These are my priorities, I guess. Nobody had a house or anything. No one spent any money for a year and we saved all that money. Then we could take all that cash and maybe start to build one of these spacecraft based on nuclear propulsion. That's the nuclear bomb idea. The other idea is to have a nuclear reactor inside your spaceship and then have like a little hole cut out of one end. So like all these crazy nuclear reactions are happening and then it goes through a hole and that's like a rocket nozzle and then you have a rocket based on nuclear fuel. This is far, far more efficient than chemical rockets. Like chemical rockets are just out. But nuclear rockets can, in principle, get you to a tenth of the speed of light. You just need to spend more money than the world has. Will the world have the money? As economies, as wealth grows, all that, we can do stuff today that we couldn't do 100 years ago. Could it happen in 100 years? Could it happen in 1,000 years? Anyone's guess. Anyone's guess. So what's your guess? I'm very curious. Next week, I'll talk about the other option, which is keeping the energy with you and beaming it to your spacecraft. But I'll see you next week.